Hello everyone. In this session, we will discuss basic storage elements. A storage element can maintain a binary state indefinitely as long as power is delivered to the circuit or until directed by an input signal to switch the states. So now we just want to store or hold a binary state for indefinite of time or until we want to store it. The most basic storage elements are latches, from which flip-flops are usually constructed. So now in this lecture, we will discuss basic types of latches, which are the first one or the most important one is SR latch. SR means set, reset. S means S for set and R for reset. So set means 1 and reset means 0. So if a latch is set, it means the main output is 1. If it is in reset state, the output is 0. The SR latch is a circuit constructed from two cross-coupled NOR gates. So the one possibility of SR latch implementation or designing is by using NOR gates. So we have here an example of NOR gates. The latch has two inputs labeled S for set and R for reset. Here set and reset, and two useful states and which are outputs as well. So first one is Q and other output is Q naught. So Q and Q naught actually represent its states. So if Q1, then it means it's a set state. If Q is 0, then it means a latch is in reset state. So there's another undefined state. We'll look into this in a while. So now if Q is 1, then Q naught should be 0. If Q naught is 1, then Q is 0. Now the circuit is pretty simple and interesting. The output of first NOR gate is being fed to the input as second NOR gate, and output of second NOR gate is connected to the input of first NOR gate. Other than that, things are pretty simple. So now let's have a look how these inputs and outputs work and how these states change from one state to other state. So now the thing to remember, there are two inputs, S and R, S for reset and R for S for set and R for reset, and two states as an output, which are Q and Q naught. Okay, so let's now analyze its diagram or circuit. This first one, let's say we want to set this latch. So for set, we need to give the input set 1 and reset 0. So it means S is 1 and R is 0. Now we have NOR gates, and NOR gate is is simple OR gate with a NOT. So if the input is 1, an OR gate simply produces 1, but the NOT gate will revert it. So let's start from here. 1 is input, R, by using OR gate, its output is 1 and it's NOT, so output would be 0. 0 is here as Q naught, which is fed to the next or first NOR gate. Now the inputs of NOR gate 1 are 0, 0, and 0, 0 is equal to 1 for NOR gate. So because R0 is 0, and by using NOT at the end, we get 1. So Q is 1. which is again fed to the second NOR gate. So here S is 1 and Q is 1. So 1 R1 is equal to 1 and NOR gate will produce 0. So again 0 here, 0 will go up, 0 0 1 Q, and again 1 NOR 1 0. So it will stop here and will start producing, start showing state 1, which is set state. Now we are referring to this row 1 0 is 1 0, Q is 1 and Q naught is 0. It's a set state. So now we are feeding an input to our latch, which are showing a state 1 are set. Now we stop giving any input to it. So let's say we just give it 0 0 now. So if we change our input to 0 0, S0 R0, now let's have a look how would this work. So the second NOR gate 0 1, it should be 0. So here is 0, and first one is 0 0, it should be 1, and 1 Q again comes down here, 1 0 0 and 1. So with the changed input that are 0 0, the latch will remain in set state. So it will store this information even there is no input given to this circuit anymore. So this is pretty interesting. It is able to hold that state indefinitely unless there is power shortage or we just change the input. Okay, so for 0 0, it will hold the previous state. So if the input is 0 0, it will hold the state that was already set. Now let's have a look on the reset option. So let me clear it. So this is done. Now we want to reset it. So for resetting, we need 0 as S and 1 at R for reset, because we want to reset it. So for resetting, we need 0 as Q and 1 obviously as QR. Now we'll start from our first NOR gate. So the input is 1 from R and it's NOR gate. So 1 means from R gate 1 means 1 and from NOR 1 means 0. So Q is 0, which is fed to the second NOR gate. So here S is 0, 0 NOR 0, which is 1. So here Q naught is 1, which is given as input to the first gate again, that is 1, and R is also 1. 1 NOR 1 is again 0, and 0 comes back to this one, 0 0 again 1, and it stops here and shows a state that is reset, means Q is 0 and Q naught is 1. So now if we want our SR latch to hold this state for us, we can just disable or change our input from 0 1 to 0 0. So now let's say we start giving it 0 0. So now let's have a look how would this work. So if R0 and 1, 0 R1 1, and NOR will give again 0, and 0 comes here down here, 0 0 1 and 1 0 again 0. So it holds this reset state, that is Q is 0 even when the input is 0 0. So even if the state is set or reset, we can change our input to 0 0. The SR latch will contain this information unless until we change our inputs, or we just set or reset again, it will hold this previous state. Now let's have a look at the special possibility. What happens if the input is 1 1? So let me clear this thing. So we have seen set state, reset state. What if the inputs are 1 1? So 1 1 means we want to set and reset our SR latch at the same time. So should it be possible? The answer is no, because the state should be or would be undefined. What should this SR latch do if we want to switch it on or off at the same time? So the state would be undefined. So let's see how this works. Let's start from S. The input is 1. For R1 it would produce 1, and for NOR it is 0. Q0 0. Q0 is given here as 0. 1 R0 1, and for NOR is again 0. So 0 again fed to our second NOR gate. 1 NOR 0 is 0, and from here again 0. So it would show a state where Q is 0 and Q bar is also 0. So how is this possible that a bit and its complement both are equal? So it means there is something wrong with this input and these states. So we call these state as undefined, which is actually a drawback or problem with our SR latch. However, this issue can be resolved by doing some additional circuitry or by attaching some additional gates to our latches. So up to now we have seen SR latch which can be set, reset, and there is a possibility of undefined state. So if by using some means we can avoid this possibility, our SR latch is able to hold a binary bit number or single bit state indefinitely unless until we change our inputs or power is down. So the summary of SR latch is asynchronous is in nature. No clock is attached, as we already knew that there are two types of sequential circuits, synchronous and asynchronous. However, we can attach a clock with these asynchronous circuits. When output Q is 1 and Q naught is 0, the latch is said to be in set state. So this is Q naught. When Q is 0 and Q naught is 1, it is in the reset state. Under normal condition, both inputs of the latch remain at 0, like S is 0 and R is 0, unless the state is to be changed. When both inputs are equal to 1 at the same time, an undefined state with both outputs equal to 0 occur. So in this case, Q and Q complement both are 0. So this is an undefined state. There is another possibility to implement an SR latch, which we call S complement R complement latch, but actually we can also call it an SR latch. It uses two NAND gates, and here you can see its diagram. It's pretty simple like the previous one, but in this method we use NAND gates, and our set and resets are changed. Means the reset is down now and set is on the upper side. It operates with both inputs normally at 1 unless the state of the latch has to be changed. So previously SR latch used to produce undefined state at 1 1, and it used to save the previous state at 0 0, but the SR latch with NAND gates will save the previous state at inputs 1 1, and it produces undefined state with 0 0. So we can look at its circuit in detail by giving it our inputs. So now let's say We want to set it. So for setting, we have to give it S naught as complement as 0 and R complement as 1. Now we have NAND gate, and NAND gate is just a complement of AND gate. So if any input of an AND gate is 0, the output is 0. So we will use that terminology to evaluate this circuit. So we start from 0. So for AND, if it is 0, answer would be 0, and for NAND, answer would be 1 here. And that one would be fed into our second NAND gate, and second NAND gate would have two inputs, 1 and 1 are complement. So an AND 1 and 1 produces 1. Now the NOR gate will produce a 0, which is a Q complement. 0 is again fed to our first NAND gate, and first NAND gate now has two inputs, 0 0, and which will produce a 1, and 1 goes down again and again. So it will stay or show one state, that is Q is 1 and Q bar is 0. It means it is a set state here, first row 0 1. Now if we change the input to 1 1, it should contain the previous state. So let's say I change this 0 to 1 here, as R complement is already 1. So now 1 here, 1 NAND 0, so it was AND 0 and it would give 1 already here. 1 comes here, 1 NAND 1 0, and again 1 NAND 0 is 1. So for 1 1, it will hold the previous state, that was set state, just similar to our previous SR latch. So we have seen set state. Now for a reset state, we will have to give S naught 1 and R naught as 0. Now we start its evaluation from 0. 0 and anything is 0, and NAND will produce 1. And this one goes here in the first NAND. 1 NAND 1, it should be 0, and 0 comes here. 0 NAND 0 1 and 1, and it will start showing a reset state. Reset means our Q is 0 and Q complement is 1. So if we want to hold this reset state for a while, then we can give this latch an input of 1 1. So if I switch or change this input to 1 here as well, so now the first NAND 1 1 0 again, and 0 goes here. 1 NAND 0, which is again 1, and 1 NAND 1 again 0. So it will hold the previous state, that was reset state. Now let's have a look at undefined. How would this undefined state work when both S complement and R complement are 0? So let's say if this is 0 and R complement is 0, NAND with 0 is actually 0, and for NAND it is 1, and 1 goes here. 0 NAND 1, it would give 1, and 1 goes here. 0 NAND 1 Q1, and 0 NAND 1 Q naught 1. So it means for an input combination of 0 0, our S complement R complement latch will give Q as 1 and Q naught as 1 again. So it means the latch is set and reset at the same time. So this is not possible. So we refer this state as undefined. So a latch can be at state set or reset at a time. Now 0 to S complement input causes output Q to go to 1, which is set state. When S complement input goes back to 1, it remains in the set state. So if we change that input to 1 1 again, so it will keep that set state. Under normal conditions, both inputs of the latch remain at 0 unless the state is to be changed. The condition that is undefined for this NAND latch is when both inputs are equal to 0. At the same time, an input combination that should be avoided. So actually, to implement this kind of latches, we need to avoid these undefined inputs, or we need to avoid inputs which lead to undefined states. Now let's update our SR latch. Now you see we have a latch with NAND gates. We will refer it as SR latch rather than S complement R complement, because the functionality of both kind of latches is quite similar. Latches can be modified by providing an additional control input. The control input C acts as an enable signal or clock. So here we attach two additional NAND gates and set and reset inputs, and the second input of these additional NAND gates is a control signal or clock here. So if this clock is 0, then there's no change or it is disabled. If clock is 1, then latch will be active and will produce or save states. The control input C acts as an enable signal. When C returns to 0, the circuit remains in its current state. So if it is 0 or comes to 0, it will hold the previous state when the clock or C was 1. So if C is 1, there is some state, let's say Sn. If clock goes to 0, it will also hold the same state, let's say Si or Sn. Okay, similarly, let's evaluate this circuit, which is a simple SR latch with an additional control input. Now we have three inputs: set, reset, and control. Control is 0 and can be 1. So if it is 0, whatever the S and R inputs are, it should show no change. Means the state will be remain previously, which was the previous state. Okay, now let's evaluate this latch from let's say set state. For set state, we need to feed S1 and R0. So here S1 and R0, and we have NAND gates, and for that we also have so let me clear this one. We start from set state, S1 and R0, and clock is also 1. So clock is 1 here and 1 here. So if S1 clock 1, so 1 and 1 1, and with NAND it is 0. The second one, NAND 1, is here. It is 0 NAND 1. So if it was AND, it was 0. Now it is 1. So let's start from here. The first 0, 0 and with anything is 0, and from NAND it is 1, which is reset. And this one, Q, is actually fed to the fourth NAND gate, and NAND gate 1 and 1 was 1, and this NAND will produce 0, and this 0 will go further here as an input, and 0 and 0 was 0, and it will produce 1. set state, and 1 again comes down here. 1 and 1 is 0, and it will start showing a set state, which is 1. So Q is 1, and eventually Q naught is also 0, which is a complement of Q. So now you see, if the clock is 1, it produces a set state. Now the thing is, if we change our inputs to 0 and clock is again 1, so here we have two changes, no changes. There are two entries for no change. So we have maintained a state set when the clock was active and the inputs were 1 0. Now let's switch our inputs from 1 0 to 0 0, and clock is still on. So let me clear these bits. Okay, it should keep the same state. So clock is again 1 here. Now the inputs are 0 0, and the previous state was set, means Q was 1 already. Now 0 0 0 NAND 1, that will produce 1, because AND produces 0, NAND will produce 1. And similarly here, 0 NAND 1 will produce 1. And the previous was Q naught was 0 and this was 1, which was previous state, and it was here already 1, and 0 was here. So the first one is 1 NAND 0, it will produce 0, and NAND will produce 1, so it remains 1. And 1 NAND 1 is 0, it is Q naught, which goes up here. So the previous state prevails, or it holds the previous state even we change our inputs from 1 0 to 0 0, even when the clock is on. So the state is same. Now we can also check whether we can switch off or change the clock. So let's say the state is 1 and Q complement is 0. Inputs S and R remain 0 0. Now we change our clock from 1 to 0. So let me Alright, so now our control input is 0. So this is 0, this is 0. You see, the output of these two NANDs remains 1. So if 0 0 NAND produces 1, 0 NAND 0 again produces 1. So the right half of the circuit doesn't change. So it means even if we change the inputs to 0 0, the previous state is saved, or even if we switch the control bit 1 to 0, it makes no change to the circuit. Whatever the inputs are, it will hold the previous state. Similarly, we can use 1 0, S0 and R1 to set a reset state. So in this case, Q would be 0 and Q naught would be 1. So in this case, even if we change our input to 0 0, it will hold the previous state, or if we switch our control bit from 1 to 0, it will hold or save the previous state. Now interestingly, the final row shows an undefined state. So it means when both our S and R are 1 1 and clock is also 1, it will show an undefined state. So let's see how this undefined state works. let me clear this one again. So in this case, S1, R1 and control is 1. So it means here 1 and 1 for the second NAND gate. So NAND gate 1 NAND 1 is 0 here. The second one is also 0. 1 NAND 1 is 0. So the first one, let's say if we evaluate this one, this will produce 0 and NAND will produce 1. Here comes 1 and 1 comes here as input. 1 NAND 1, so it will produce again a 1 which is fed to the first NAND gate. 0 NAND 1 1 and the bottom one is also 0 NAND 1, so it will produce set state for both. So it means it is set and reset at the same time. So Q is 1 and Q naught is again 1, means undefined. So what should we decide from this output, whether the latch is set or reset, because it's set and reset at the same times. So again, if we even attach a control input or a clock with our SR latch, it just enhanced its functionality a little bit, but there is still an issue of undefined state. Control input C is 0, which disables the circuit so that the state of the output does not change regardless of the values of S and R. When C is 1 and both the S and R inputs are 0, the state does not change again. So there are now two possibilities to hold or make no change to our SR latch state. An undefined state occurs when all three inputs are equal to 1. As we have seen it, SR latch with control input are used to construct other latches and flip-flops. So these are basic types of latches which are called SR latches, and we can construct further latches. So in the next video we will see how we can change this SR latch so that it can take single input, so there is no possibility of set and reset. So that is called D latch. We will discuss in our next session.